about finding the measures of arcs. So today we're just going to be measuring our arcs in degrees. So there's going to be a relationship between the angles in a circle and the arcs of a circle. So their degrees will have a relationship. So first we're just going to fill in these blanks up here at the top with some definitions. So it says a central angle is an angle whose vertex is at the center of the circle. So this angle here would have a vertex at B, right? B is at the center of the circle, so this is a central angle. The sum of the measures of the central angles of a circle with no interior points in common is 360 degrees, which you guys already knew. You knew a circle was 360, right? Okay, so within our circle, we can have three different kinds of arcs. The first type is a minor arc. Okay, these all get their names based on how many degrees they are. So a minor arc is going to have a measure less than 180 degrees. Okay, we also have a specific way to name each one of these types. So a minor arc, one that measures less than 180 degrees, is going to be represented by endpoints. Okay, for a minor arc, you will use 2 letters. So an example of a minor arc, something less than 180 degrees. That means it's going to go less than halfway around the circle, right? So an example of that in this picture would be from A to C, right? That's clearly less than 180 degrees. So if I was to name that arc, I use its 2 endpoints, which are A and C. So my example here would be AC, okay? But we also put a little symbol above it to show that we're talking about an arc as opposed to a line or a line segment, okay? Our symbol that we put above it is just a small arc above the 2 letters. Okay? All right, so minor arc measures less than 180. Any guesses on what the measure for a major arc is? More than 180, right. So this is actually going to be between 180 degrees, but no more than 360, right? Because that would have mean you've gone all the way around the circle. So between 180 and 360 degrees. This one is going to be represented with 3 letters. Or 3 endpoints. Okay, so over here, if I'm looking at this figure, I'm trying to pick an arc that is greater than 180 degrees, so it needs to go more than halfway around. So I could do from A all the way to C the other direction, right? And that would be between 180 and 360 degrees. So I actually end up containing 4 letters there. So it doesn't matter which letter you choose to put in the middle, but you're going to start with your beginning point, end with your last point. So A and C will go on the ends. You pick a letter that falls between them to put in the middle. So you could name it AEC or you could name it ADC. But you have to put that 3rd letter in there so that they know that you want them to go the long way, not the short way to AC like we previously did. Okay? So we would name it ADC or AEC, and we still put that symbol above it. All right. And then our last type arc is our semicircle. So a semicircle is going to measure exactly 180 degrees. And it is also represented with 3 letters or 3 points. So over here in this figure, there are 2 semicircles that are clearly marked for us. You could either go from E to C over the top or from E to C around the bottom. Okay? The way we know which one you're referring to is by which letter you put in the middle. If you were going around the top, A would be your middle letter. If you're going down the bottom, D falls in between those 2 points, right? So an example of how to name one could be E, D, C. Okay, we also do have what we can call an adjacent arc. Remember, the word adjacent just means they're right beside each other, right? So, if you have adjacent arcs, they are going to have 1 point in common. Okay, for example, over here, this arc EA and this arc AC are right beside each other. If I named them, they would have the point A in common, right? Okay. All right, then we have our arc postulate. So this says that the measure of the arc PQ, which would be from here to here, plus QR, from here to here, plus is equal to PQR. So if I added those 2 together, I get the entire piece. The measure of the arc matches the measure of the central angle in degrees. Okay? So if they told you that this angle was 5 degrees, then this arc out here also 5 degrees. Okay? They have the exact same measure. So this angle in here has the same measure in degrees as the arc out here. So central angles and arcs have the same measure. Okay. All right, so then it says something about concentric circles here. It says concentric circles lie in the same plane and have the same center, but they have different radii. And all these circles would be similar in size. So this is an example of a concentric circle. They both have the same center right here, but one of them has a much smaller radius than the other, right? They're similar shapes because they are the same shape, they're just different sizes. All right? In addition to that, we also could have congruent circles, but congruent circles would mean they're exactly the same, right? Not similar, but exactly the same. So these would be circles that have the same radius. Then if 2 arcs of one circle have the same measure, they are said to be congruent arcs. So we can have congruent circles, and then we can also have congruent arcs within the circles. And congruent arcs would have the same length. Okay. So there is a difference between arc length and the measure in degrees of arcs. So first of all, quick summary of what we've covered so far. We know that an arc has a measure which is equal to the measure of the central angle. Okay? This is measured in degrees. Okay? I don't know why it keeps cutting out some of my letters, but an arc's measure is a degree between 0 degrees and 360 degrees, right? It can't be more than 360, it can't be less than 0 if it's going around a circle. within that 0 and 360, you can have different kinds of arcs. Our minors, our majors, or our semicircles. Okay. In addition to having a measure in degrees, an arc also has something that we call arc length. Okay, and we're going to go over that part tomorrow, but an arc's length is not measured in degrees. So we'll have to convert from what we're currently looking at into the correct measurement for arc length. Okay. But all you need to know is that it's directly related to the circumference, right? If I'm going around a circle, that's the circumference of the circle. All right, so knowing what we know about central angles and arcs having the same measure and our three different types of arcs, let's flip it over onto the back and look at some examples. All right, so the first thing they ask us to do is to determine each central angle that would be used to create this circle graph. Okay, so currently it's split into percentages, right? A percent is out of how many? 100, right? So if I have 25%, that is the ratio of 25 out of 100, right? And I'm looking for how many degrees that 25% is in the entire circle. So I don't know how many degrees it is, but do I know how many degrees a whole circle is? 360, right? So I could just cross multiply here to solve for the angle's degree. So what would we get when we cross multiply here? Okay, and then we divide and we solve for x to get good. So x is 90 degrees. Okay. All right. That next section looks like it's 23%. So you guys said that that percentage is out of 100. We want to know how many degrees that is in our circle, which is a total of 360. So again, I'm just going to cross multiply, right? So I've got 23 times 360, and then I divide by 100. So what is x going to be this time? Very good. So x is 82.8 degrees. Okay. And the next one, looks like that one is 24%. So 24 out of 100 is equal to x out of 360. So what would x be this time? All right, our next section looks like it's 10%, so that's 10 out of 100% equals x out of 360 degrees. So what would x be this time? 36. All right, and then our last section is 18%. So 18% out of 100% is equal to x out of 360 degrees. What is x this time? Okay. All right. Okay, let me ask you this. If you had a chart like this with different variations of percentages, is it always going to add up? If you add up what you get here, is it always going to add up to exactly 360 degrees? Why not? I heard some yeses and I heard some no's. So if you said yes.
Because it might not be a perfect number.
Right. If we get some weird decimals here, eventually we have to round, right? So if you round maybe a decimal here and a decimal there, and then in the end you went to add them back up, you could be slightly off, right? Because your decimal is an estimation, not an exact. So if you had another one of these and it doesn't add up, then it might be just because you rounded if it's just a little bit off. Okay. All right. Example number 2. So let's look at finding some arc's degrees here. It says in circle E, the measure of angle AEN. So angle AEN would be this angle in here, right? Says that that measure is 18 degrees. Well, if that angle is 18 degrees, how many degrees is the arc AN? 18 degrees, okay? All right, then it says that JN is a diameter, so this line is a diameter, meaning it splits it in half, right? Okay? And JES, the angle JES here, is 90 degrees. Well, if the angle JES is 90 degrees, how many degrees is arc JS? 90 degrees. Okay, so keeping that information in mind, they want the measure of these arcs. Well, AN, you guys already told me the measure of arc AN was 18 degrees. All right, it was the same as its central angle. Okay, the next piece they ask for the measure of is the arc JA. So from there to there. What would we do to find the measure of the arc JA? Right. We know that JN is a diameter, which cuts it in half, or 180 degrees. If we just subtract out the 18 degrees, that will leave us with JA, which is how many degrees? Good. All right, and then the last one that they asked for is the measure of arc JAS. Okay, so I go from J to A to S. So what could we do here?
360 minus 90.
360 minus 90, very good. Okay, so 360 minus 90 leaves us with, good. All right. Okay, number 3. This one says that in circle R, the measure of angle QRS right here is 40 degrees. Well, if that angle is 40 degrees, we know that QS, the arc, is also 40 degrees, right? Angle SRT right here is 90 degrees. Therefore, the arc ST is 90 degrees. It says that there are 2 diameters here. XS is a diameter, and also QV is a diameter. Determine whether each arc is minor, major, or a semicircle, and find the degree of the arc. It looks like it got rid of our symbols here, but it says to find the measure of arc XQ. Okay, so XQ would mean to go the short way to get there. So from X to Q, from here to here, is that a minor, major, or semicircle? Minor, right? It's clearly less than 180 degrees. Okay, what could we do to find it? Right, 180 minus 40, because we know that XS would be a semicircle. So that would mean it has a degree of what? Okay. Next, it asks us to find the measure of the arc VSX. Okay, so V to S to X. That means I'm going all the way around there. So VSX would be a major, Okay. So the only part not included here is this piece right here, right? How many degrees should that piece be? 40. Why? Vertical angles, very good. So if it's 360 degrees all the way around and the only piece not included is the 40, it would be 320. Okay. All right, then they have QXV. What type is QXV? Semicircle. Good. So it has a measure of exactly 180. All right, and then the last one TSV. What type is TSV? Major, okay. Okay, so to go T, S to V, the only part I'm not including is this portion here, right? How can I figure out how many degrees that piece is? Right. So we know that this portion has to be a 90-degree angle. 40 of it's already taken up. That leaves us with 50, right? Okay, so if I don't include 50 degrees in the entire circle, then it must have a measure of, perfect.